So this is going to be partly a repeat of last year's summit, but with some things added and some things cut out. So I think I have to start from rewind the tape a little bit to get everyone on board with the signing. So first of all, why should we even sign the Eiffel events? Well, that's one of the problems of having a shared bus is that more or less everyone can publish information. You could have authentication for publishing to the bus, but there is no other form of access control in terms of who can say what. So if you receive an event, you don't really know who actually sent it. There could be information in the event indicating the sender, but you have no way of verifying it. So it's actually surprising that this hasn't been addressed earlier within the companies, I think. We have been signing some of our events for the past year, almost exactly. And I think we are alone in doing that. Is that true? Yeah, seems like it. So far. Yes. So that's slightly disturbing. So I think the need is quite clear. Also, it will of course also make sure that the integrity of the event is kept. But I think the authentication of the sender is the most important part. And previous presentations on this theme have been more open questions. We haven't got at that time so far in solving this problem. But now we are on the verge of getting to the bottom of it. So just a slight recap. An event that's signed gets, you populate the meta security field with the author identity, which is a distinguished name describing the author or the sender. And then you have an integrity protection field that contains the signature and information about the algorithm used. So this is part of the event itself. So you have to do some trickery to produce an event like this, since it's part of the payload that you're signing. So it's a bit of a catch-22, but it's a pretty simple algorithm for doing it. This, of course, increases the size of the event by upwards of 100%, depending on the size of the signature. In this case, it's using an elliptic curve algorithm, which I think produces a shorter signature. So that's probably a good idea. Also better performance, I'm told by people who know. So the support in the ecosystem is pretty limited. The first one out the door was the .NET SDK developed by DoWhile a few years ago. It has sort of support because it relies on always generating a new key pair and including the public key in the payload itself. So while it allows you to check the integrity, you would have to blindly trust the public key itself. So it doesn't help at all with authenticating the sender. That could, of course, be updated. But yeah, I was a bit surprised when I read the code to actually look at what it was doing. The Go SDK has full support for signing and verifying. And that's what we're using for most of our signing needs. It'll be expanded shortly with a couple of example programs, just simple CLI programs that you can use to sign an event and verify a signed event. It's meant sort of as examples of how to use the SDK, but they will also be fully usable as standalone tools if you you're working in a language that doesn't have support for signing yet, for example. Obviously, since you're going to be forking off a process each time you sign or verify a message, it's not for high volume message sending, but for low volume, it's going to be perfectly fine. So I hope to get that in place within a couple of weeks. We have some internal leads with TypeScript developers who should sign in and verify events. And finally, the Eiffel Broadcaster Jenkins plugin also has full support for signing events, and that's one of the senders that we use to announce our artifacts. I think Fredrik, Volvo uses the Eiffel Broadcaster plugin.
Yes.
Yep.
And There was a company, I forgot the name, who made another Jenkins plugin, and I asked them to contact the community, but I don't think they have that.
Okay.
It was it had some enhanced capability of linking events.
Okay.
I don't remember. It was a consultant firm that I heard over the shoulder in the office area and asked them, "This is something you should."
It sounds really interesting. So yeah. Okay.
Was it next? Yeah?
Sounds familiar.
Yeah. Too bad Nikolai isn't here.
Yeah, it's Nikolai.
Yes.
He was.
Okay. Well, I can talk to him and see what have you guys done. Okay. Back on top again. The problem with this is you receive a signed event and you want to verify it. You need to know what public key should we even use. Without that, you can't verify it. So what the .NET SDK did was they included the public key in the event payload. There's a key field for that also in the integrity protection field. So this would protect against corruption, but that's not really the main reason you would sign it. But it wouldn't do anything for authenticating the sender, except for one thing, namely, similar to when you log into a server with SSH. The first time you do it, you have to accept that server's public key, and then it's saved perpetually. So the next time you contact it, you can verify that you're getting the same key. You could do sort of the same thing here, where the first time you see an event from a particular sender that's signed, you could save that public key, and then the next time you would use that key again. So it means that if the first message you received was authentic and correct, all the rest would be okay as well. But there's no way for you of knowing whether the first one is okay. So it's not great in any way, but it's better than nothing. Again, if the first one you receive is from a malicious actor, you would just blindly accept all the malicious events sent afterwards. So not a great solution. And also this makes the events increases their size by another 100% of the original size. So then you're at 3 times the original size, which probably isn't a problem, but no, it's not great either. One thing we could do is update the protocol to have a field in the event payload for the certificate. And this certificate could then be signed by a certificate authority that's trusted by the receiver. This would completely authenticate the event, so it's fine. And of course, the certificate's subject field would then have to match the identity in the event. So this should be perfectly fine. Again, it would require a protocol change that I think is a little bit unnecessary. And again, it would vastly increase the size of the event payloads. And just lots of duplication in all forms of storage. So I haven't been pushing for this one either. What we've been doing for the past year is that every consumer verifying events, which in our case is just one, they would be configured more or less statically with a list of mappings between the sender identities and the public key. This works great, but it doesn't scale, of course. What happens when a sender needs to roll a new key, for example, and how do they even know which ones are interested in verifying? I mean, it absolutely doesn't scale. But for the past year, we haven't had any real need for scaling either, so it's been okay. But we're now adding more senders and more receivers, so we have to do something about it. A slightly different take on this, if you have some kind of shared configuration containing all these mappings. This could be, you could have a Git repository containing the public keys and the sender of identities. You could have consumers fetch these files or an archive of the files, or whatever representation you choose through a web service or a file shared. any way of distributing files you could use. The drawback of this is that you would have to trust anyone who has access to the source of this configuration, because they could impersonate anyone. And depending on the choice of distribution, that could be quite a few people. You have both, owners of the service, you have people in IT who have access to the service, and it's pretty hard to make this reasonably secure. But it certainly solves a problem of scaling, at least. But not the security problem. And now we're getting to what I think we should be doing, namely, oh yeah, no, this is also a variant. Yes, this is what I think is okay. So you have a shared configuration again. You can distribute the configuration in any way you want, but the difference is that instead of just having public keys and identities, you have certificates that are signed by a certificate authority that everyone can trust. That way, there's no point in closely guarding these files by themselves, because even if you would attempt to include a malicious certificate or something, it wouldn't be correctly signed, so any consumer would just ignore them. So this means that as long as you can protect the private key that's signing these certificates, you'll be fine. And that's fairly easy. There are ways of making secure certificate authorities out there, so there's no need to reinvent the wheel. Still, there would have to be a trust in the certificate authority, but if we can't trust a certificate authority, there is very much in our world that's not going to work. So it's a reasonable assumption we can do that. So yeah, let's spend a few minutes on this slide. So this is pretty much what we're intending to implement in the next couple of months, I would say. So before walking through the workflows, let's introduce a few of these boxes here. So the CA is the certificate authority itself. We're going to use most likely HashiCorp Vault, which has built-in CA functionality, both in the Community Edition and the Enterprise Edition. We're using the Enterprise Edition, so we get a few more features and authentication and stuff, but it's probably the Community Edition is going to be fine. When you're using it, I don't think you even have access to the private key used for signing the certificates, even as you as like an operator of the CA. So that bodes well for security. However, the clients are going to request signed certificates, probably shouldn't have direct access to the CA and its APIs for various reasons. Security being one, abstraction of backend service being another, for example. So our plan is to have a very lightweight certificate authority front end, or whatever we want to call it, that interfaces with the CA when it receives requests from clients, but also takes care of the authentication of the certificate signing request. This is what we talked about yesterday. Namely, if it receives a certificate signing request from someone who wants to get a signed certificate for a particular identity, you have to make sure that whoever requests that is authorized to act as that identity. Otherwise, you could just request a certificate for anyone, and then you wouldn't buy anything. And how that's going to be done, we'll see. It could be a fairly static mapping of like usernames to distinguished names, for example. We'll see how we do it. And this is something that might be fairly organization specific. So although we could open source the CA front end, it would probably be maybe not so generic. It would depend on the CA backend you use. If you don't use HashiCorp Vault, a lot of it is going to be useless to you. Depending on how you do authentication of the users sending the requests, it's going to be different. So I guess we'll see when we've created it, maybe run it for a while, and we'll see, is this something that's in practice going to be useful for anyone else?
it actually could serve a benefit to have this sort of front end, because if you have a different back end, then the front end can sort of act as sort of an API neutralizer, so
Yes.
it can be more generic. So it actually can make sense to have that one, so it can be, you can have anything in the back that you want.
Yes, yeah, that's definitely one of the reasons. Definitely. Yeah, you just API abstraction. So we look at the actual flows here then. A producer that wants to sign events would generate a key pair using any means, maybe just an OpenSSL call with some inputs for the certificates. Well, for the key pair doesn't include any of that, but once you have the key pair, you would run another command to create the certificate signing request, which is a small data file including the identity that should be in the certificate, the requested validity dates, various other features. Should it be a web service certificate, or there are many options you can set in certificate signing requests, it seems, but not all implementations support them, and sometimes they're silently ignored. So it's you might think that you can use a particular feature that's in the spec, but it turns out that hardly anyone implements it. So keep it simple. And I don't think we need to complicate it either. But for example, if you want to use for the CA, in our case, we're going to have our own root certificate authority. So it means that any consumer that wants to verify events, they would also need to be sort of primed with the certificate of our certificate authority. One could imagine a world where the company, be it the IT department or someone else, has a root certificate that we would have in turn as our upstream certificate, and that their root certificate would be well known on all the hosts in question, where then in that case, it wouldn't have to configure each consumer with our event signing certificate. But again, that would then require some features in the CA and all the components to be able to make that really secure. Since the IT department owning, or whoever owns the root certificate, they want to limit who we can issue certificates for, of course. And that's where we get into the features that aren't necessarily supported in client libraries. So once you have the certificate signing request, which isn't really secret, doesn't contain any private keys or anything, that would then be sent through some kind of web interface or other API to the CA front end. This would definitely require authentication, as we said earlier, and the CA front end would have to verify whoever authenticated, are they allowed to request this particular certificate. Assuming they are, the CA front end would request a signed certificate from the CA. That should be a very quick operation. You get back the signed certificate and you would store it somewhere. We're probably going to use a Git for that purpose. We have all the necessary infrastructure for it. You can use it to see, inspect the history of the certificates and so on. So I think it's going to work out fine. But again, you could just store them somewhere where it's accessible by HTTP. And because we have it in the Git repository, there will be IFIL events sent when they're updated, so the consumers can just fetch the new information. So the producer has an event. They would use their private key to produce a signed event, and they would send it. Of course, this signed event would need to have sender identity matching their certificate, of course. They don't really need to get the signed certificate back from this request here. I guess it wouldn't hurt, but they don't need it, really. On the consumer side, they would receive a signed event. They would somehow obtain all the certificates available, and they would somehow have to figure out which public key they would use for the verification. As far as I know, there's no really good way of doing that apart from like brute force. If you have multiple public keys matching the identity, you would have to just try them out until you get a match. And if you reach the end, then I guess it wasn't okay after all. You could use the validity dates of the certificate to narrow things down. And we'll talk more about that on the next slide. And you can also use some clever caching. For example, if you have a set of certificates that was used by a particular, that you have for a sender, it's very likely that they don't switch between those certificates randomly. It's probably just that they, now and then, they roll a new certificate. So the last one used is probably the one that's going to be used again. So that would be the first one to try. So I don't think it's a problem that you have to do a linear search through all the certificates. That shouldn't be a performance issue. Of course, it depends on how often you roll the certificates. Chances are you might not implement automatic rolling of certificates that often or at all. So I don't think it's going to be a problem. Any questions on the flow here, or how it works? You might not be crypto expert, but neither am I. But I tried this out the other week, and it works. In that case, on to the question of validity. You should take the validity of the certificate into account, especially if you're going to roll them at any frequency. And the nice thing about the flow that I just described, that you could basically roll them quite often, since everything is going to be automated. More of maybe some practical issues of doing that, because someone's going to have to request the certificates. Go back for a while. In this case, if it's a human doing this, you could use, multi-factor authentication and all that. If it's a machine requesting the new certificate, then where are the credentials for that machine account stored? And is it sufficiently safe? So it could be that I would say that it's safer for a human to request a new certificate not that frequently, rather than having a machine requesting it, once a day with a secret that needs to be stored somewhere. But anyway, regardless, you have the validity of the certificate, and you should make sure that when you receive an event, like these three here that are signed by certificate X, when you receive them, the certificate that you found to be matching the event you received should be within that certificate's validity date. So they're not reusing something old. Of course, this is being an asynchronous system. There is a risk that when you're processing and verifying the signature, it might actually, or you might be, after the validity. That's a possibility. So it's probably wise to have some kind of grace period afterwards, where you accept a slightly out-of-date certificate anyway, just because, reasons. For example, you could have, say you have a long-running test job that loads the private keys when it starts, and maybe it runs for a week and doesn't reload the certificates during that week. That should still work, but it depends on your circumstances. And I don't know, maybe you should also take into account the timestamp of the event itself, because this model of checking the current time against the validity of the certificate, that works fine when you're receiving events in real time. But if you're inspecting events in the past that you find from an event repository, you should verify them as well, ideally. Depending on if you've set up your service that inserts things into the event repository. If it verifies all the signatures so that you can sort of trust the event repository to be to have verified everything and that there is no tampering, but then you're introducing a need for more trust, then maybe you wouldn't have to verify it. But it's probably wise to verify it also for old events that you extract. But then you can't look at the current time, of course. You would have to look at the time when the event was transmitted. and that would be the timestamp in the event. But technically, there's no rule that that timestamp needs to be equal to the time it was transmitted or the time the event happened. It should be, but there is no mechanism for verifying it. So yeah, I don't know how to deal with that really.
The important thing is to make sure that the timestamp of the event is within the range of the validity of the certificate.
Yes.
As long as that is true, it's not really that matter. So you still have to sort of imagine yourself as a time machine. When you validate old events, you have to go back to that particular time and the time range. So as long as the event has been produced within the valid range of the certificate, I think you're fairly good.
Probably, but you could have a case where someone obtains, a certificate with this validity here, and they would, at time over here, they would send an event with a timestamp within here. It wouldn't make sense. If you look at it, you would see that, wait a minute, this event, this clearly happened over here, but the timestamp is from weeks ago or years ago. That's something fishy is going on.
Mm-hmm.
But that's what I mean. There's no verification of the timestamp.
Yeah.
So
unless we have some sort of mechanism to verify the validity of the event when you create it. But it's all in the interest of the receiver to know that the producer is the one that makes that validation. So you don't know.
No, exactly.
Malicious one can actually try to trick you in all the possible ways that they can.
Yeah. So there's probably further study necessary to cover all the possible holes here, but that's also something that could be used when you're inserting it into the event repository. Initially, that you're verifying the signatures, but also checking that the timestamp is within some reasonable range. Again, you would have to trust that the event repository has done that verification when you extract it, but that could be one way anyway to decrease that risk at least.
You even have one more, let's call it sinister corner case here, and that would be if you would have a security breach. Someone is stealing your private key, for example. You want to sort of talk with your authority to retract your current certificate. That has to be put into special cases because you need to know that that certificate is no longer valid and you need to propagate that information so you will no longer accept signing on that. And that could be a tricky thing to do, but it's one of the corner cases that might be interesting if you want to play really hardball here.
Mm-hmm. Hopefully it's not actually that difficult, because if you use a good CA, it has support for certificate revocation lists. And I looked quickly in HashiCorp Vault, and it looks like it just handles everything. So a certificate revocation list is a list of revoked certificates. Very simple. By default, it'll be empty. And all the certificates will include the URL of the CRL. So it's easy to obtain it for everyone who has the certificate. And the CRL itself is also signed by the CA. So it should be okay to have any distribution method of that CRL. And Vault deals with all that. Check whether you can obtain the CRL without authentication, which would be the desired behavior, but I haven't checked that. So, and there's just a one-click button. If you look at a certificate that's been issued by the CA in the HashiCorp Vault interface, there's just a button for revoke certificate. So it looks like it's very, very easy to use. Of course, this would have to be implemented in the clients. It's not magically done by any signature verification libraries. You will have to explicitly ask for certificate revocation checks, probably also validity checks as well. I think by default, it's just going to do a plain cryptographic verification of the signature using the public key. So code needs to be written for this, but it's still it should be pretty standard stuff. And this, I hope I'll also be able to implement it in the CLI programs in the Go SDK. So that's reference implementation. Yes.
When you were revoking a certificate, isn't the validity, the time validity changed also.
I mean, the validity of the certificate itself won't change.
Yeah, but I'm thinking the validity timestamp, because I guess if you're using one certificate and you get some events and then it's compromised, revoke it, will you also invalidate all the events sent by that certificate backwards in time?
I mean, that will be up to the one doing the verification, I would say. Again, it's I don't think any of the signature verification libraries does anything automatically. So I mean, they're orthogonal operations. So you could check the validity or verify the signature, then you would check the validity dates, then you would look it up in the CRL, and it's up to you to decide, what do I do if it's in the CRL? Do I care about, would all of the events signed by that key, historically, would they be considered compromised, or is a particular cutoff date I should use? I guess then that's probably information that wouldn't be in the CRL. Probably something you would have to obtain otherwise. If you know when the compromise happened, you could maybe configure the verifying clients about this, but I don't think it's built into the CRL standard as such. But again, I'm not a crypto expert. I've learned a lot about this in the past couple of weeks, so but that's how I think it works anyway. But that assumes that you know when the compromise took place, which, yeah.
We have a question from the crowd here. Emil Bäckmark is asking, could it be possible for a consumer to manage thousands of events per second, given the time penalty of verifying the signature of each event?
I haven't benchmarked this, actually. I could get back to that question later today, because we have traces of our service that runs the verification. I can probably get an average time for the signature verification. But sure, it adds a cost, sure, but it should be pretty CPU bound, so it should be possible to scale horizontally.
You may even consider to evolve certain, schemes in order to minimize the footprint for doing this. For example, like group signing, or maybe having some intermediate signing, which is more lightweight, but still secure enough. So there may be optimization based on the performance situation that one can develop, I guess.
Yeah,
So
yeah,
this
quite
is the
possibly.
starting point.
I haven't at all looked at the performance. It's been good enough for us so far. But I can get numbers probably until after the break.
Are you happy with that, Emil? Yeah, I think so.
Yeah,
Thank
very
you.
good. But again, I can get back to you on that one. Yes. Yes, that depends on your implementation. I probably wouldn't bother doing it in the CA front end. I expect it to be very, very rare occurrence, and I wouldn't be surprised if we implement support for CRLs in a million places, and then after 5 years we never revoked a single certificate. But it should be quite enough. But when you use that feature in the CA, it's going to immediately update the CRL that's available for download. So if you do revoke a certificate, all the clients should respond very quickly. Of course, I'm sure they have some kind of caching, of course, but it should be a quick response. I think that was, yes. Any more questions?
We thought about what type of events should be most likely targeting the need for signing. I guess all events may or may not be at the same level of interest to be.
Yeah. For us,
the chain as well, because we may have sort of linked events, and in order to make that chain true, then I guess you need to check on your linkage and so forth. But that could just be huge.
Yeah, it could. It's for us the important important thing has been the artifact events, since there we have, the digest of the files themselves. So that's a really key one. Activity events, we don't really care about those, but we're signing them anyway. But then, of course, CLMs would be important. So they, in our case, trigger various release flows and so on. So it's a bit scary that they're not being signed right now. It's yeah. You have to do by on need and the difficulty of implementation was built in a day, so you have to do one. You eat the elephant one bite at a time. All right, thanks.
Has the signing been sort of discussed in before, like the events and we know that.
Any such discussions too much?
No, because I don't think that I could be wrong. Off the top of my head, I don't think the CMS has support for signing. Of course, it uses cloud events, and that would if you use cloud events, but I don't think they have any specific support there.
No, I think that's probably a difference between IFL and other event protocols, is that they are more focused, is my interpretation of triggering workflows when things happen, and the security isn't that critical. But we are conveying information about release, requesting releases more or less. We are and digest the files and all that, and that it's inherently more security sensitive. Does Emil have a comment?
Emil has a comment.
Yes.
He doesn't think CDA events has support for signed events.
Yeah, that's what I suspected.
And I suppose if you expand that into the monitoring area, I guess they haven't even come that far.
No. I mean, in that case, you would have no, definitely not for individual pieces of telemetry. I don't think they'll ever add that, but they do probably have support for authenticating, say, open telemetry collectors when they send telemetry to an upstream something. There are probably ways of adding authentic. Well, I know there is. At least you could use MTLS, for example. But then you would accept anything they send, regardless of. You're trusting them, the sort of the downstream OTel collector. You would trust them that they have received everything from trustworthy source, which may or may not be true. If you're running an agent on a host, for example, there's probably ample opportunity to inject interesting information.
But then if OpenTelemetry is more focused on observability, it's not that much, or as a thing with triggering, then that is probably the reason why they haven't gone into that area and looked at it too deeply. But I also agree. I mean, if you're doing instrumenting code that's like milliseconds, then trying to sign those parts would probably be very expensive.
Yeah.
Compared. So
well, you have a really, really clever scheme to sort of balance out the performance and the overhead. But I do believe, I mean, we have more compute power and we talk about AI and doing things, and so we don't know what will happen. All we know is that security will sort of become an increasingly important part in all areas. So if you want to do something bad, you try to go for the weakest spot, inject whatever you can. So even telemetry may be sort of such a spot in the future.
I mean, we're digressing a bit here, but sure, if you submit logs through an OTel collector or some kind of agent on a host that you connect to through maybe a local TCP socket, that definitely could be exploited. I mean, traditionally, you write log files to disk. Those would you would at least have normal file permissions on those, so it would be harder to inject malicious data in the logs there. That could be easier with such agents, but yeah. Any final questions or comments?
you had some question yesterday, Boo, that we postponed to the day.
About the sort of authority.
Yeah.
As a sort of an extension on the signing part to figure out sort of if the not just the integrity and the identity of the sender, but also whether the sender has the the proper authority to express the information that has been within the event in the first place, and mechanism to verify that. That's sort of an extension of, it's not sort of the integrity problem or identity problem, it's an authority or authorization problem that can be added. So I think that's sort of a new thing that we can work on.
Is the authority, is it on the sender or the receiver?
No, it's on the sender, definitely.
Why?
Well, because the sender, we
If
sort
you
of
do it the other way around.
claim, well, you need to prove that you have the right to speak on behalf of what you say. So you need to prove that in one way. In order to do that, you need to have an authority registered somewhere to basically connect authorized authors and the object itself and link them together. That could be used in order to match if the person that is having the event has also the right to express the information here in the step. So it's sort of a different level, but I think that may be sort of an extension to, once we get this running, we can go to the next step. I think
exactly.
Upon this one, to build the authority partners if we want to.
Yes. We did something similar for our consuming service where we basically have a mapping for particular event types, which are the authorized distinguished names that we even care about. And that's orthogonal to what are the public keys and identities that we accept at all. So otherwise we could potentially have a situation where say the key used to sign the activity events sent by Jenkins is compromised and starts sending artifact events, for example. Those shouldn't be trusted, even though we trust the event itself, but well, no, we don't trust the event itself. I mean, we trust the key itself, and it verifies that the event checks out, but it's not allowed to say anything about any artifacts, only activities. So we do have such a mapping table, but it's not centralized in any way. And I don't know if it should be, because it depends on the consumer, possibly, whether you should, what you should accept.
Exactly.
Maybe.
What you should accept. It's on the receivers.
Well, the acceptance
You
one,
need,
yes.
you need to know what you need to do. And of course, then you say that, okay, you need to have some sort of, how do you verify that and what is the metadata around? But still, in there you can have a lot of stuff sent on that channel, but what you are accepting as a receiver is at the end of the day, was the key point.
Well, it depends on, I mean, if we look at the ordinary life, you will be bombarded with information or claims or statements about objects where very few person has any authority to make any statement. People are just stating things on their belief. So one have to distinguish between what may be sort of factual information based on an owner, or statement that is sort of, I think, or I refer to something without me being the owner, but I still have the right to express myself an opinion about the object itself, even though I'm not owning it. So there are different ways of handling information about objects, whether you are or not the truth or owner. And to manage that is going to be a quite complicated thing.
Yeah.
But that's sort of an extension of the authority mechanism that could be implemented if we like to.
The interesting question would be to sort out who would approve the authority. That's kind of a delicate
Well,
question.
you need to have sort of a bootstrap mechanism that is sort of, whenever you create an object, you need to declare who's the rightful owner, in the first place, to map that. Once that has been done, then you can sort of write from that. But you need to have that sort of bootstrapping information in your system somewhere. And more to that, and adding on to the integrity part as well, if you would have, for example, the scenario of multi-vendor pipelining, which means that you have sort of different entities and you have sort of integrity within, and when events are sort of crossing those entities borderline and the verification, then you need to sort of globalize the mechanism to validate those events across different entities. Of course, which you can do, but you need to have that in mind when implementing. Where will these events go? Will it be sort of local to my environment, or would I actually sort of communicate those events to other parties? And are they interested in validating those events? In such case, you need to pass over certain information for their validation process as well.
Yeah, it sounds like a topic for future summits.
Certainly does.
All right, well, thank you.